All right, good morning. So it's pajama day today, so we should all be nice and comfortable and be ready to go, and it's all good, right? Okay. So the packet that you grabbed as you walked into the room today, yes, it's a little thick, okay, but it's all notes. Okay, I think so. I should really look at the packet. You might have thrown a review. Oh, we did. We did throw a review at the tail end. Yep. So the last page again is the review assignment for this section. What we're looking at here is we are looking at dealing with 6.6 today, tomorrow, Wednesday, and Thursday. Friday we've got Battle Royale in the morning, and so I don't really know when we're getting out of Battle Royale, so we really don't have anything planned for Friday. It's going to be kind of like a review day, extra practice day, work on some problems kind of a day. And then DeMauve starting on Thursday and Monday of next week, and then Roots on Tuesday, Wednesday, with a little review action on Wednesday too. And right now we're tentatively planning a test next week, Thursday, which then leaves next week, Friday, the day before spring break. That leaves us to sign up for registering you for the dual credit aspect of it. And because, you know, we were supposed to do that back in September. You know, September, end of March. It's pretty close. You know, so we'll get that done on that day. So that's the plan. Okay? So today we're going to start talking about section 6.6. It's all about complex numbers. Okay? You've seen them before. Okay? I can't remember if you dealt with them in Algebra 1 or not. I know for sure you did them hardcore in Algebra 2, but I don't remember if you got to them in Algebra 1 or not. But otherwise, make you think back about a year. It's good times. It's good times a year ago. Okay? What's the deal with I? Imaginary numbers. Yeah. What's the square root of negative 1? I is the square root of negative 1. Yeah, because what that does, if we go square root of negative 1 there, and what that does is that allows us to, if we've got a function, let's say, if it's a quadratic function, it would allow us to get the two roots, the two answers, if it looks like that. Right? Where those roots or those answers are where it crosses the x-axis. Well, if that parabola doesn't cross the x-axis, we got to find those two solutions. And they're in the imaginary world. Or in the cubic world, it would look like that. Okay? Or in the quartic world, it could look like this. Or it could look like this. Okay? On the bottom one, it would be where we'd have 4 imaginaries. On the top one, we'd have 2 imaginaries. And so on and so forth. That allows us to complete all of the roots, all of the solutions for it. Okay? So we're going to base it off of the fact that I equals the square root of negative 1, and that I squared is equal to negative 1. Okay? That's what we're going to base off all of our imaginary numbers on. Okay? Which then allows us to, well, we can simplify the square root of negative numbers. So for me, because I do things a little differently, I'm a different breed of cat. Okay? All right? So this would be, to me, the square root of negative 1 times the square root of 81. Sneeze coming. Excuse me. Which then allows this to be 9. The square root of 81 is 9. And the square root of negative 1 is I. So this is really 9I. Not plus or minus here, because we're just finding what's called the principal root. Okay? We're not solving. If we were solving, then it would be plus or minus. Okay? All right? And then the square root of negative 12, Well, that would become the square root of -1 times the square root of 12, which is the square root of 4 times the square root of 3. The square root of 4 is 2. The square root of -1 is I. So we write this as 2I times the square root of 3. We put that real number first, then the I, and then the square root at the end. Okay? Or if we had variables in there too, we would also, like we could go 2xy cubed I times the square root of 3. Okay? If we wanted to. Okay? We won't, but that's how it would go. Okay? What about 8I squared? What would that be then? That'd be 8 times -1, right? Which is -8. What about I cubed? Can we simplify I cubed? It is not just 1. So we could rewrite this as I squared times I, correct? Right? And I squared is -1, and I is just I, so this would be -I. You were thinking of the next one. Yep. Okay? So let's talk about those powers of I. Okay? So I, we know, is I. I squared, we know, is -1, right? I cubed, we just found, that was -I. Just so you know, I put a little curly Q on the bottom of my eyes just to signify that it's I's and not a straight up and down 1. Okay? But that's just me. Again, different breed. Okay? What about I to the 4th? That'd be like I squared times I squared, right? Which would be -1 times -1, which is +1. Okay. I to the 5th power then, let's roll those over. I to the 5th power would be like I to the 4th power times I, which is excuse me, I was put -1 there, which is +1 times I, or it's just I again, right? What about I to the 6th? -1 is our guess. Okay, so that's I to the 4th times I squared, which is +1 for I to the 4th and -1 for I squared, so that becomes -1. I to the 7th, -I, following the same pattern. I to the 4th times I cubed, which is +1 times, and then from over here, that's -I. So that's going to be -I. I to the 8th is going to be I to the 4th times I to the 4th, which is +1 times +1, which is +1. Right? Okay. Following that pattern, I would like you to figure out for me what I to the 17th simplifies to be, and what I to the 23rd simplifies to be. Somebody walk me through I to the 17th.
Well, we know that it goes in like intervals of 4. Like the repeating of the I, -1, -I, and then 1 pattern. So I got rid of like 16, maybe that's 1. So I just have I to the 1st, which would just be I.
So you went here, you said, I found that this was I to the 16th times I, right? Which I to the 16th then became 1 times I. So you got just I there.
Follow factors of 4.
Yep. Yep. Okay. Somebody give me another way that they did it. Anybody else do it a different way? Nobody wants to talk today? What you got, IDB?
I mean, mine's kind of the same. I just broke it up and I did I to the 8th times I to the 8th.
Okay, so and then you probably broke it up even more, to like I to the 4th, and 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 then I, right? Like that? Or I to the 8th and I to the 8th, because we had those from above?
Yeah.
Yep, that works, and so then that got you I. Okay, anybody else? Another way? How I do it, I take 17 and I divide that by 4. Right? 17 divided by 4 is 4 with a remainder of 1. So that tells me that I am in the, I have 1 left over on my exponent, which is just I. Okay? I divide by 4. If I have 0 left over, then that gets me positive 1. If I have 1 left over, it's I. If I have 2 left over, it's I squared, which is negative 1. If I have 3 left over, it's I cubed, which is negative I. Okay? That's how I do it. Okay? So then I to the 23rd, if we follow along with Hannah's way, then this would be I to the 20th times I cubed, which is going to be 1 times I cubed, and I cubed was negative I, so then this becomes negative I for the answer there. Okay? If we do it IDB's method, I to the 8th, I'll go I to the 8th this time. I to the 8th is 16. There's 20, and there's that one then, right? So then all of these, that becomes a 1, that becomes a 1, and that becomes a 1, leaves me with I cubed, which then is I squared times I, so then we get negative I there. Okay? My method, 23 divided by 4 is 5, remainder 3, so that leaves me with I cubed, which is negative I. Again, 3 great methods there for you to do. It's a personal preference as to how you do it. Okay? What I would like you to do now for the next, I'll give you 10 minutes or so, is I would like you to turn to the bottom of that page. There's, tap the brakes. I got one more thing to talk about. So let's not do that yet. I forgot I had this slide. Okay? So, complex numbers. A complex number is a number that is broken down into 2 parts. It has its real part, and it has its imaginary part. Okay? Any number can be written as a complex number. Okay? For instance, 17 can be written as a complex number. 17 is 0 plus, tap the brakes. I was thinking ahead to the next one already. 17 is 17 as a real part plus 0 imaginary part. Okay? So that's a real number written in complex form. An imaginary number, I'll say negative 8i, written in complex form, would be 0 minus 8i. Okay. We just in math don't write that 0 part, right? So if I don't write that 0 part, then this part is gone, and I just get 17. In the in imaginaries, I don't write that part, and I just get negative 8i. Okay. All right. So we're going to use that we're going to be adding and subtracting and multiplying and dividing real numbers, complex numbers, and imaginary numbers. So what I would like you to do now for the next 10 minutes is I would like you to, there's 4 problems here on the bottom of the first page, and then there's some more multiplication problems at the top of the next page, and then there's some dividing problems. I want you to spend time working out what you need to do. You don't have to do every single one, okay? But if you are struggling with multiplication, do some more multiplication problems. If division gets you, do division ones. I know the answers are at the bottom of the second page, but I wanted to show you a little worked out with them too, just so you kind of see what's going on. My one piece of advice on these first 4 is tap the brakes, slow down, read the problem. Okay? Which is actually 3 pieces of advice, but we'll give it to you as one group. Okay? What you are going to think in your mind, because I know it, I've seen it 1,000 times. You see 2 sets of parentheses, like in in 3 of these problems, and you want to multiply. Because that's what we've ingrained you in. When you see 2 sets of parentheses, you multiply. But these are not multiplication problems because they have addition or subtraction in between the 2 sets of parentheses. So tap the brakes, slow down, and think. Okay? Look, read, and think. Okay? When you get to these, then these become those multiplication type problems. So then this would be 8 minus 10i if I went here, and then plus 12i and minus 15i squared if I go like that. Okay? And then this minus 15i squared really becomes plus 15 because negative 15 times negative 1 is positive 15. So then this becomes 23 plus 2i for that one. So there's 7 and 8 worked out. Okay. For number 9, this is really 3 plus 2i times 3 plus 2i, which then becomes 9 plus 6i and plus 6i plus 4i squared. Positive 4i squared is really negative 4, so this becomes 5 plus 12i on that one. Okay. On number 10, you could first distribute the 5i into one of the two parentheses, or you could leave it and then do your multiplication or distribution afterwards. 12 minus 3i plus 8i minus 2i squared. This is positive 2, so this really is 5i times 14 plus 5i, which then would become 70i plus 25i squared. 25i squared is really negative 25, so this really is negative 25 plus 70i. Okay? And the last one is dividing, where you have to think using conjugates. Okay? Conjugates are like this one back here in number 8, where we have those two, where we just, the only thing that's different is the sign in between the real and imaginary part. And then notice here, we get rid of the imaginary part when we multiply the conjugates together. So what I have to do on this one is I'm going to take 6i and I'm going to multiply both top and bottom by the conjugate. And the conjugate then would be 3 plus I. So on top here of this first one, I get 18i plus 6i squared. On the bottom, I get 9 plus 3i minus 3i minus I squared. So this becomes negative 6 plus 18i all over 10. Right? Okay? Which then written in complex form would become negative 6 over 10 plus 18i over 10. And then I would reduce those to be negative 3/5 plus 9i over 5. And that then is my complex form. I split it up into the real part and the imaginary part. Okay? Have a great day.